Hi, I'm Meredith Blackwell. This is Don Pfister, and we'll introduce him in a minute. We're here at the Mycological Society of America annual meeting. It's on the campus of the University of Florida at the Hilton Hotel. And we are recording mycologists to talk in the oral history for Mycology project that is in its third year. Today is the 11th of July, 2022.
Great. Thank you, Meredith. Terry, we're here to talk to you about how you got into mycology, but we really always start with people talking about their early experiences, where they're from, whether they knew about fungi as a kid,
Sure.
you know, how they got into it. And I know in your case, you studied vascular plants and did a lot of other work before you found fungi.
Kind of.
So introduce yourself and give your last name, because we
Sure.
didn't do that.
I am Terry Henkel. I am currently a professor of biology and botany at Cal Poly State University in Humboldt in California. And in reference to Don's first question, I actually grew up in the Midwest in rural southwestern Ohio. And I think my interest in fungi stems from the fact that I grew up in a rural existence. So a lot of what we did as kids was played around outside and in the woods. So I had a lot of direct experiential stuff with nature, plants, animals, and even though the local non-indigenous culture that I grew up in was strongly mycophobic, our family did go collect morels in the springtime in the deciduous woodlands. And one of my earliest memories along those lines is the early springtime odor of the soils, warming up in the woods with my mom, looking for morels under declining ash trees. So I always think back and think maybe somehow just the soil environment and looking for the mushrooms and how things felt at that early age might have planted the seed in later interest in fungi.
So southwestern Ohio.
Yeah.
Is that, what county was that?
Well, Preble and Darke County. So really where we grew up was around New Paris, Ohio, which is about 30 miles north of Oxford, where Miami.
Well, that's why I was wondering if you'd gone there to school.
No. So when I eventually went to college, I picked Ohio University in Athens, Ohio. A couple reasons for that had to do with it was still an in-state school where I could get as far away from home where I grew up and still be in-state. And once I went down to visit in Athens, I realized, wow, this place is like a wilderness wonderland compared to like the glaciated farmlands where I grew up, because it's a lot more woods in that part of Ohio. It's the unglaciated part of the state. So I went to Ohio U. I took a Botany 101 class and got hooked on, I want to be a botany major, basically. So that's what got me started in like college level studying of biological sciences. So the mycology part's coming. Should I just go right in?
Well, yeah.
Yeah, so as botany majors at Ohio U, which was really cool because at that time we had 3 mycologists on the faculty, none of which studied true fungi. We had a Plasmodiaphora mycota guy, James Brazelton, Charlie Miller, who I think was a zoosporic, more of an oomycete guy, chytrids, which are true fungi, and Jim Cavender, who is dictyosteliid cellular slime molds. But Jim, Dr. Cavender had a really strong influence on me. He taught upper division general mycology when I was a major there. And Jim was a little bit eccentric in a lot of ways, but he made sure he got his students out in the field and stuff a lot. And, exploring fungal diversity and habitats in nature as part of the class. And that's kind of got me on the track of focusing more on fungi in the context of being like a botany major in college, at least. And it kind of led to the next step for me, because I finished at Ohio University, had my degree, didn't know what to do. So go to grad school and stay in school for a while was the only thing I could come up with. So I'm talking to Jim Cavender, like, where should I apply? And of course, he's from the University of Wisconsin-Madison lineage with Martha Christensen, Ken Raper, Jim Cavender, pretty strong mycological lineage from up there. And he's like, why don't you look into the University of Wyoming? Martha Christensen's out there and she's real good. Maybe she's taking grad students. Long story short, I applied to like 3 programs out west. One was Oregon State. I wanted to work with Jim Trappy. I remember calling Jim on the phone and he's going, well, Terry, yeah, you could probably fit in, but I got like 9 grad students right now. That was like 1983. So Jim was overloaded with grad students, Trappy. And I ended up getting in Wyoming. Martha wanted me to come on board. At that time, she had just finished Mike Allen's PhD, for instance, so they were switching kind of out of Martha's soil microfungi focus into glomalin fungi and endomycorrhizae studies. So I ended up at Wyoming and I did a project, a master's project on arbuscular mycorrhizal fungi in the sagebrush steppe in the cold desert of Wyoming. So that was like a major ecosystem shift for me for being a botany major, and still something I could do with a mycological bent for research that would still utilize the kind of bizarre grassland and steppe ecosystems out in Wyoming.
Once I went into the city, and there was a horrible sleet storm, but we got out anyway and walked out into the, what is this shrubby stuff?
Yeah, outside of Laramie?
Yeah.
Yeah, okay.
And my gosh, they were huge puffballs. I'd never seen these huge puffballs. There were all kinds of mushrooms when you got out there in it and walked.
Sure, if the precipitation conditions were just right, so you must have went in there after. It
was after rain. Yeah, it must have been, because the storm was, it had happened, but there were probably earlier ones. It wasn't that storm that brought them all out. But I was shocked. I just thought, this is so barren, it's just not going to have anything. And it was these huge puffballs. I'd never seen the likes of.
So Don mentioned the plant thing. Of course, I was a botany major as an undergrad. I took tons of plant courses, plant ecology. I basically, from day one, I'm kind of like a generalist. I like it all. I like natural history when you boil it down to a nutshell. But I also developed an interest in just symbiotic relationships early on when I was an undergrad, because I was thinking of going into lichens for my master's program. But I knew I could work with some kind of mycorrhizal system if I went out to Wyoming and worked with Martha, which I did. So the unconventional track sort of characterizes my trajectory, because once I finished, I got my first paper published out of my master's in New Phytologist, of all things. One paper, Henkel, Smith, and Christensen, 1989, on arbuscular mycorrhizal fungi differential impacts on western wheatgrass growth under different strip mine reclamation regimes, something like that. But I was tired of being in school at that point. I was pushing like 10 straight years of being in college, 4+ years to get to undergrad, 4-ish to finish my master's. At that point, I just wanted to work some kind of field biology job that would keep me in the field, but I'd get paid for it. And I wanted to get out of Wyoming because the winters were driving me crazy. 9 months of winter, etc. So, a long story short, I gravitated down to Gainesville, actually where we are right now. A friend of mine had finished his master's at Wyoming, was down here working on his PhD, also on endomycorrhizal stuff. And so I had a connection here. I came down to live with him. I immediately got a job within a week with one of the faculty members in the forestry department here, doing like sample collection and stuff for him in one of his field projects. And so before I knew it, I was living in Gainesville, about the exact opposite of like Laramie, Wyoming, ecologically. So, when I was out of school, I had no intention of going back for a PhD at the time. And leaving out a lot of details, I worked field biology jobs in Florida for a couple of years. None of them had a strong mycological component, but I was getting paid to be in the field. Didn't have the headaches of doing my own research and stuff. So I ended up getting a job for the Smithsonian Institution to collect plants for them in Guyana. So I'm going to condense a whole bunch of history here because basically I was looking at like an 8-year-long gap year at this point. Well, when I included the Smithsonian stint after my master's, before the PhD. Because I had 2 years doing remote areas plant collecting for Vicky Funk at the Smithsonian, sending specimens up to them from the most remote areas of Guyana. But I still had this strong like fungal interest. And by the time I finished the Smithsonian job, it's like, I want to study something that I've discovered that nobody knows anything about that has a mycological component in Guyana. I called you, as a matter of fact, Meredith. You probably don't remember, but I do, because I'd been out of school for a while. And I wanted to, the only thing I think to do would be to get in a PhD program where I had an agreement in advance with my advisor that they would let me run with developing a project around this system that I discovered in Guyana. I remember calling you, and the one thing that you said to me that I've never forgotten, because I'm going, yeah, I'm kind of, I have some taxonomic expertise, but I'm kind of ecology, and you told me at that time you need to be more than a single type of scientist to succeed in mycology these days. You got to have multiple skills. You don't remember saying it, but you did.
Sounds right.
But it worked.
Right.
It worked.
Yeah,
Tell me I was right.
Yeah, and then my supervisor at the Smithsonian is the adjunct professor at Duke, so I'm calling Vicky like, where do you think I should apply for school and stuff? And she immediately said, well, why don't you call Rita Svilgalis at Duke? He wears Grateful Dead t-shirts into the lab every day, or tie-dyed t-shirts. Anyhow, long story short, I called Rita and I said, I've stumbled on these forests in Guyana. They're loaded with ectomycorrhizal fungi. Nobody knows anything about it. Ectomycorrhizal fungi in the neotropics yet. I'm looking at the literature. Nobody's, this is an undiscovered, undocumented system, and I want to develop my PhD research around it. You think I could possibly fit that in at Duke? One thing led to another, and I applied, went up and gave a seminar. Rita's like, well, you got to come up and give a talk before I was even accepted into grad school. That was interesting. The whole botany department was there.
Early interviews.
Yeah. Long story short, in that respect, I got into Duke and suddenly I was back in academia after 8 years of being out. About killed me the first year. I'm in there with a whole cohort of grad students that are like 10 years younger than me, although Tim James was one of them. And Tim really helped me deal with it psychologically. But I got back into it. I ran with it, got tons of in-house grant money to develop my fieldwork program down in Guyana, and I did all my dissertation research basically documenting this system and getting some preliminary data on the dominance level of the ectomycorrhizal trees, early glimpses at the assemblages of ECM fungi that are associated with them, et cetera. Before I know it, Dave Largent's retiring out at Humboldt State. So you know how the job announcements used to come around hard copy and people would pin them up in the department? One of the Humboldt State ones goes up in the Duke Botany Department. Everybody's going, Henkel, that one's got your name on it, man. It says basically field mycologist wanted. It still had, we are seeking a field mycologist, and everybody, I'm still writing like the last chapter of my dissertation, not even thinking about the next step, but I'm also approaching 40 years old probably at that point, or mid-30s to the late 30s, and it's like, wow, having a job someday with some kind of job security might not be a bad idea. So that was cool. I applied for the Humboldt job and made the cut with phone interviews, went to the on-campus interview, and before I knew it, they were calling me and offering me the job. So I'm going, okay.
You were the last field mycologist.
Anyhow, that was cool. So I'm going, all right, I know the teaching loads are heavy out at Humboldt, but they're not going to tell me what to teach, and it's all mycology. And it's a great place to live for fungi, where mushroom season lasts all winter long. And it's a beautiful area ecologically, environmentally. It's kind of off the grid for California, that far north up in the state. It's not a huge development place. It's kind of, you know, my kind of country place that I would prefer to live in relative to a big city, and I've been there ever since. Yeah.
And you've been in Guyana ever since.
I have been in Guyana ever since.
How many years? How many seasons?
Yeah, well, let's see. If I count the Smithsonian plant collecting days, is where I first got my feet wet in that part of South America. It's been about 30 years. But when I went back to Duke and started doing like real field work focused on this mycology related project, that would have been late 90s, so that's around 25 years. There was just too much more stuff left to document and discover to like drop that program when I moved out to Humboldt. And it's been cool because we're part of the Cal State system, so we only have master's level grad programs, not PhD, which was a perceived limitation of the job, but fortunately I've been able to recruit like a number of eventually highly successful grad students that were actually Humboldt undergrads, botany majors that I already knew really well because they'd been in several of my classes, that I recruited straight into master's projects that involved doing work on one group or another of fungi from Guyana, and was able to take students, have been and continue to take students down to do their field work down there, as well as doing some local projects in Northern California.
It's a really neat area. I hear about it when I was at LSU from Kathy Aim, when she was there.
Yeah.
And it just sounded like heaven for a mycologist.
Yeah, well, for a macromycete guy, like a mushroom guy, it's really good because I have to teach like a couple of courses a semester. And aside from like a plants and civilization service course I do every spring, they're all mycology in some way or another: forest pathology, general mycology, mushroom identification. We start getting rains typically in like late October, but the wet season continues in the near coastal area all through most of the spring. So we really have a full-on mushroom season all winter long, late fall and pretty much all winter in a normal year. So from a teaching standpoint, it couldn't be better because you can have fresh material to work on in your labs. You can get the students out in the field as much as you're willing to take them out in the field. They can do their own collections for classes and stuff and find the material. Like in most other schools, if you're a midwinter in a class like that, you'd be digging out the dried specimens and pickled stuff.
Yeah, people having to devise their whole syllabus around when they can, the fungal groups, when are the fungal groups going to be out, yeah.
So for me, that's been really rewarding because, I'm gainfully employed as I move into this middle and later stage of my career. I mean, Cavender always said to me, college professor's the best job you can ever have. You get paid to teach people about nature, and you got a whole bunch of time of the year to do other things. So,
I wanted to ask you something about Cavender, and it's got to do with carling. We've been looking for a photograph of carling, and the only one we've been able to find was one with Cavender.
With Jim in the picture?
Or maybe I'm mixing up, maybe it's Brazelton. That would make more sense, wouldn't it?
Yeah.
Do you know if they had any connection?
Well, Jim, I believe, Brazelton, who was also a Jim, I believe he's deceased now. Jim's still living, Cavender.
Yeah, no, I can't remember which one it was, but do you remember either one of them having a connection with carling?
No. They had a connection with each other because they were both in the same department.
Yeah, and they both were in, Jims were in my mycology textbook when I was in school. It was amazing that these two guys were in the same school and there were chapters devoted to their organisms which weren't fungi.
Well,
right. But they were very interesting organisms. Yeah. Yeah, but I think it is Cavender who's photographed. Now he was at Columbia.
Yeah.
So neither one, though, that I know of had a connection with Carling. With
I don't know where Jim Brazelton's like pedigree came from. I mean, he worked on Plasmodioptera. That's fairly bizarre. I don't know. Maybe he wasn't like a sparrow student. I don't know. But Jim was from the kin raper lineage of Wisconsin.
Yeah, he worked with Ken Raper. Yeah. Interesting.
So one thing I've found, like just being a mycology instructor, is just, and maybe some other folks have said this if you've gotten into like teaching mycology in these interviews, is like just rolling with the changes, especially from the systematic standpoint, especially because we actually don't have a current textbook that's good from a fungal biology standpoint that's also organized under our current concepts of like systematic groups and stuff. I'm still using Webster and Weber 2007, which is great for like basic fungal biology stuff, but it's already fairly strongly out of date in terms.
Yeah, we haven't really talked about that, about approaching teaching and how hard it is in a way now.
Yeah.
Because of the changes that have happened, and there's so many groups now. You know, one used to be able to have several orders in a phylum that you'd talk about and so forth, but now it's very hard.
There's not one phenotype in a higher taxonomic group.
Yeah.
And that is a real problem, I would think.
If you're doing a certain dimension of that I've found challenging is doing labs. You know, with macromycetes, you know, you traditionally organize, you know, we've got the guild mushroom and bull eats lab. We got the gastroid fungi lab.
Can't do it. Well, you can do it that way, but
you have to constantly point out really how these are coming out of totally different lineages, and it's convergent evolution. I've found that actually works. You can still organize the gastroid fungi into 1 or 2 long labs worth of material for the students, but you have to really drill them on the convergent evolution aspect. And
you have to get them to look at the right characters.
Look at the right characters.
One of my colleagues, a mammologist teaching evolution, wanted me to put together a group of fungi, you know, represent a family or something. And I put Hymenocetaceae. That was the group I gave him, and he absolutely wouldn't believe me at the variety of those things because they just weren't anything alike in their morphology, the breeding body morphology.
Yeah.
I think he dumped them. He didn't use them at all.
So why don't you tell us a little bit more about the expeditions and the requirements and how you do this?
Yeah. Well, I've always been an outdoorsy kind of guy and done a lot of backpacking and like to go into wilderness areas. I had that whole background when I got the Smithsonian job. And I'd gone to Guyana because I had some mutual friends that were actually from the country. And I did 3 months of backcountry trekking, and it's hardcore primary lowland tropical rainforest out there. It's not easy to get around. You got to rely heavily on the indigenous guides to walk on trails through the mountains, go from one village to the next, that sort of thing. So, in fact, I think having done that trekking trip helped me get the job with the Smithsonian because Vicki Funk hired me just based on a phone interview. Basically, yeah, you got a master's in botany, but you were in Wyoming, so you probably don't know much about tropical plants yet, but you just did 3 months of trekking in Guyana. So I'm going to give you the job because 90% of carrying that out is figuring out how to do the expedition logistics and also how to deal with, properly deal with the indigenous people that you have to depend on as like field assistants and guides and so forth. So I ran remote areas expeditions for 2 years for the Smithsonian, but collecting plant specimens. And I took the skills needed in preparations from food and material standpoint, like gear to set up your camps, packed ration buckets, also hiring the Bush charter aircraft to drop you off at selected remote airstrips in the interior of Guyana to start the expeditions. So I continued doing that because the Decimbi forests that we've been studying, these ectomycorrhizal dominated systems, they're in the mountains in western Guyana. I knew the area somewhat from plant collecting trips, so I basically took the same kind of expeditionary approach to go in and establish my initial field sites and semi-permanent base camps to do like multi-year studies on the mushrooms and other ecological stuff we've been doing. So to do that, you basically, once you're in country in Guyana, you have to have a carefully calculated list of dried rations that will support the number of people in your mycologist team, plus the number of indigenous field assistants that you're going to hire on site to be a part of your team the whole time. You can't go in there and not feed everybody. So that's kind of complicated, and it ends up being a lot of weight, and you have to pack everything in waterproof buckets. You have to hire the airplanes, which are extremely expensive, and you have to calculate your ingoing weight down to the milligram practically, because the planes have very strict weight limits. And somehow within that context, you still have to calculate and take in enough survival food to keep everybody going for the expected duration of the trip. So you do all that and you get into the field site, and then we're, with the mycology work, we've got a semi-permanent base camp that we rebuild every time we go back to this same site, because we have permanent plots set up that we've done repeated, like sporocarp sampling in, below ground mycorrhizae sampling in. And once we're set up at that base camp, it's kind of like being in an extremely rustic field station. We're operating, going out into the field and doing collecting and stuff and coming back every day for 4, 5, 6 weeks at a time. So that part's really cool once you're out there, because, we set up a kitchen camp. We take turns doing like the camp cooking. You can bathe right in the river. It's a remote mountain stream, totally pure water, above the waterfalls of the lowlands, so you don't have piranha and other sorts of aquatic things that are typically dangerous in lowland neotropical rivers and so forth. None of them are up in the mountains. No electric eels, no piranha, no candiru fish that swim up your urethra and get lodged. So, and then if you hit it at the right time from a fungal standpoint, mushroom standpoint, it's just an unbelievable explosion of diversity, especially in those transition weeks coming out of the dry season into the main rainy season. It's spectacular because a lot of folks will drop in for a one-off visit in some neotropical lowland rainforest, and it's like, where are the mushrooms? You don't just see a lot of macrofungi, maybe other than conchs, polypores on logs and stuff, at any given random time that you might go in. But I've learned from the phenology thing of the transition from the dry to the wet season, at least in these Decimbi forests, that there's an explosion of fruiting body production. But then it kind of levels off as you get deeper into the rainy season. So we've always tried to time our trips to like hit what we think are going to be those key transitional weeks from the dry to the wet season.
So it's before the real rain comes.
Well, it's when the real heavy rain is starting to come in, but maybe not with as frequent duration, like every third day or so there'll be a heavy downpour with 2 or 3 dry days in between. Mm-hmm. In Guyana, as you move into like June, which is the peak of the heavy rainy season, it's pouring like that pretty much every day, and the forest is so wet it seems to have a dampening effect on mushroom fruiting body production.
So how long will it last? Like several weeks?
4 to 6 weeks.
Okay.
Yeah, and it takes a lot of money to pull off one of these expeditions. Between the starting in the U.S. and international plane tickets down to paying your local assistants in the field a day wage when you're out there, and the hiring the planes, it runs. You can't do a trip like that for less than $20,000 to $25,000 for one expedition when you're starting with coming in from out of the country, etc. So if you got the time, fortunately, the main rainy season, the good mushroom time in that site in Guyana coincides with our academics.
Yeah, that's a problem sometimes.
Yeah.
So how do you let the plane know when to come back? Or do you set it
You look
ahead?
at the calendar, you set it up.
Okay.
Of course,
No telephones or cell
I have a
service.
satellite phone now. That's like a new innovation as of about 15 years.
Do they have one too? Or they have
Or-
a phone you can reach?
You can call their like a landline at their office in Georgetown using a satellite phone. But it was not that way in the early days. We used to literally go in the bush with two-way radios, which if you were lucky in these remote mountain valleys where we were, you could radio out on a certain frequency to another village in the interior that was not too distant. There's no way you could call directly on the radio all the way to Georgetown, the capital city. So for a lot of years when we felt we had to get some kind of communication with our contacts in Georgetown, it would be trying to connect with the closest like native village that had a radio set that were a little bit closer to Georgetown that could potentially relay the next message into a radio operator in the capital city. What that meant is that it was almost impossible to execute like a quick or relatively quick evacuation in a case of emergency.
Yeah, that's what I wondered. Nobody got sick or
Well, we've been down there a long time. We've had all kinds of different sickness, but nothing severe enough to evacuate. But I had one traumatic injury on an individual in my group, a really bad twisted ankle. It almost looked like it was broken, but it was a situation where we had to get her out of the bush. But it was in the sat phone era. And we weren't too far from the airstrip, so we didn't have to carry her a long distance. The native guys, they have a whole technique if they have to carry somebody out that's sick or injured. And they tie a hammock on a long wooden post that's long enough for 4 or 5 or 6 people to take turns carrying with the person literally hanging in, the injured person hanging in a hammock, and they can carry them long distances through the forest in case of emergency. We've never had to do that.
good.
Well, it's tough going.
Yeah.
You know, it's a different kind of expedition than many are used to. Yeah. Now you're doing a similar thing in Africa.
Yeah. So that came out of these early germinating ideas that myself and Kathy Aim and some other folks that have actually worked with me in the field in Guyana had, that the most closely related trees in the Fabaceae to these Dicymbi trees in the Guyana Shield are actually African leguminous trees, not the other leguminous trees that were really widespread in the neotropics. So we already knew from like traditional taxonomy in the legumes and also early molecular systematics legume papers that were coming out that our ECM host genus, it's surrounded by other leguminous trees in that system in the Guyana Shield, but its closest relatives within the family were Central African, West African, and also documented ectomycorrhiza formers. So we had this idea that we got to shift this focus over to Africa sooner or later to begin sampling over there and eventually try to address some questions about biogeography and the fungi between like those northern Gondwanan land masses that have closely related host trees. Of course, they're now separated by continental drift. Is there some kind of signal of common ancestry maybe between those two and possible vicariant distributions in the extant fungi, ECM fungi from the two systems? So I convinced NSF that that was a good idea finally after 3 years of pounding in the proposal. So we got a good deal of money, me and Kathy did, to pick up with a similar kind of sampling regime in Cameroon, in southern Cameroon, which is like the western extension of the Guineo-Congolian rainforest system, and there's extensive areas that have their own species of fabaceous or legume ectomycorrhizal host trees that are really dominant.
And they're related to Dicymbi?
Yeah.
You know.
They're in the same clade, within the Fabaceae, the subfamily Deuterioideae. And almost all the genera and species within the genera that are in that subclade of the family are known ectomycorrhiza formers, and there's very few other ECM formers outside that subclade within the Fabaceae. There's a couple other ones. So yeah, that work's in progress. We did 5 years worth of field work in Cameroon between 2014 and 2019. Ridiculous amount of ECM fungi, like in a confined spatial area, 3 1-hectare plots and the immediately surrounding area for general collecting from a centrally located base camp. About twice, we've picked up just as sporocarps, about twice as many ectomycorrhizal fungi in an equivalent kind of area space in the forest in Cameroon. I mean, when we finally get the data worked up and we're able to publish that just alpha diversity paper, it's going to show that it's the single most rich single site anywhere on the planet that's been fully documented for ectomycorrhizal fungal diversity. There's no question, because we're approaching like 400 morphologically distinct species that we can recognize just on morphology are different species across Russula, Lactarius, and the various bolete genera. 20 species at least of Cantharellus in that system. And you know, we're like somewhere around 180 species just collected and documented as sporocarps in Guyana with all those years of sampling, which is pretty diverse. You know, and probably 40 or 50% that we've picked up on with root tip sequencing that we've never been able to match with any of the sporocarps, so additional cryptic diversity in the system. You know, we're approaching 400 species just as sporocarps in Cameroon, and we already know from preliminary assessment of our below ground molecular data that there's about 40% of the fungal species OTUs off the root tips that don't match any of the fruiting bodies that we've got. So it could have like 600 species in like 3 hectares of forest maybe.
Yeah.
It's fantastic.
Yeah.
Yeah, I think Brunson found that the things that fruit aren't the ones that are the most common of the...
And vice versa, at least that study they did in Point Reyes. Yeah, they had a Swillus that was, I think, fruiting everywhere, but they found the genets were really small below ground, and an Amanita that was a more sporadic fruiter that had big genets below ground, or the other way around, but yeah. So that's been really cool. And you know, I was predicting to Kathy early on when we got the grant, it was like, oh yeah, but then we went, oh shit, now we actually have to do like at least 4 or 5 years of extended field work in a system we've never worked in the lowland African tropics, and malaria and all the other diseases and stuff. You know, we thought that out in advance, but we weren't that confident we'd get the grant.
Kathy went and took a course, I think, on snake bite and everything else.
Did, actually. She had this great like emergency medical, I think the British Geographic Society like training program. So we did that, and then you know I finished the last year of money that I had for field work. I did the last Cameroon expedition in 2019. So I'd pretty much exhausted the grant funds for the field work. We've got massive amounts of sequence data, enormous numbers of vouchered collections, and the pandemic hit. So we're slowly trying to work up some of the taxonomy of the different taxa, doing some epitopification of species that were previously described but are only known from the type collection, you know, from the Congo. There's a bunch of stuff in the Belgian herbarium like that. We've got a lot of new species, but especially the sort of synthetic aspect of the comparative diversity with Guyana and some biogeographical questions. We're still in the process of trying to wrangle up the data to develop a story, so we haven't published anything extensive on that yet. And the pandemic kind of slowed everything down.
We probably should close, but I'll close on the happy note that I heard that proposal was the highest ranked one in that panel.
Really?
Mm-hmm. That year, when you finally got it in the third year, you must have got it going right.
Yeah.
But it was number one in the...
Well, I'll make a follow-up comment to that while we're closing, that, you know, I was reworking that same proposal 3 summers in a row. And the second year, we didn't get the funding, but the review comments were really quite light. And there wasn't a whole lot that I could see in that year's proposal that I really needed to change.
So you didn't?
Well, I did make a few changes, but nothing like fundamental and super substantive.
The panel probably changed.
The panel probably changed. Either way, I thought it was a good proposal too. And at that point in time, the panel did, and it stimulated
One
us
panel liked it.
to be able to take our, remote areas fungal sampling methodology to Central Africa.
Yeah.
It's
No,
really neat.
it's great. It's fantastic work and
Yeah.
not likely to be redone.
Well.
Anything comparable is not going to happen very quickly.
Yeah.
So,
And-
but
and-
it's great. Thanks
Yeah.
for talking about it.
Sure.